So this unit is all about scatter plots. This video we're going to just be focusing on what is a scatter plot. So if you look here, we have the definition. So the definition is a scatter plot is a graph of plotted points, right, or coordinate points that show the relationship of bivariate data. So we need to probably unpack this word bivariate because it's probably the first time you've ever seen it. It starts with this prefix bi, which means two, right? Just like a bicycle means it has two wheels. And then this back part, variate, that just means variable. So really what we're talking about is we're talking about two variable data. Up until now, you guys have only worked with single variable data, and we've done that with dot plots and circle graphs and a couple of other different ones. So this is going to be the first time you've been introduced to bivariate data, which just means there's going to be two variables instead of just one. And it kind of makes sense when you think about that. It's a graph of plotted points, right? So remember, because points come in an XY combination, right? That coordinate pair. There's an X value and a Y value so that we can graph it. So that's why there's two variables. They're going to be X and Y. So right off the bat, I just want to show you what a scatter plot looks like so you have a general idea, and then we'll talk a little bit more about the little bit of in depth about the pieces of it. Okay? So what does a scatter plot look like? It just looks something like this. We'll talk more about this example later, but this is just to get an image. So all it is, right, here's your y-axis, here's your x-axis, right, so this is just a graph, and then these are all just coordinate points. These are just points that are graphed on the chart. So that's all a scatter plot is. It's just a graph like we've been working with a bunch of points put on that graph. That's a scatter plot, right? And it's called a scatter plot because they're not connected. Like we've been dealing with lines this year. And we would put all these points on the graph, and then we connect them with a line to draw the image, right? That's not what a scatter plot is. These are all individual points. And in a scatter plot, each of these points represents one thing. And it could be a whole bunch of different kinds of things, right? It just depends on what your data represents. We're going to talk about two different kinds of examples just to kind of unpack this a little bit, but it could literally be anything. Like the sky's the limit. They use these to represent all sorts of things. But two possible things that could be represented in a scatter plot could be like, you could put like sports balls, right? So each one of these little dots would represent a different kind of sports ball. Or maybe it's people, right? Which would mean that each dot represents a person. So that's a person. That's a person, that's a person, so on and so forth. Okay, so these dots are just one something. Okay, and then I just want to talk about how do we represent them then? So like if we were going to break down sports balls, there's lots of different ways we could represent or talk about or classify sports balls. We could talk about the diameter of the ball. We could talk about the weight of the ball. We could talk about the density. Hopefully you guys remember from science class, density just means how tightly compacted it is, right? We could talk about the shape, right? Because it could come in all sorts of shapes. I know I wrote ball up here, but it could, right? It could be a hockey puck, which would be a cylinder, or it could be a football, which is a little bit more oblong, right? So there's different shapes to the ball. And of course, nowadays they come in all sorts of colors. Back in the day, they used to all just be the classic color for each of the different sports balls. Now that you can get them in all sorts of different colors. These are all different ways we can represent a sports ball. Now, when we're dealing with scatter plots, these variables, though, have to deal with only numerical data. Numerical just means it has to be number, something that we can represent with a number. 1, 2, 3, 4, so on and so forth, right? So like if we think about shape, we can use this to classify sports balls, right? Like, if I say it's a sphere, there's a lot of spherical shaped sports balls, right? Tennis balls, golf balls, basketballs, lots of them. If you get into some of those other kind of shapes, there's not as much, like a hockey puck, right? That's a cylinder. Off the top of my head, I can't think of any kind of cylinder-shaped sports ball outside of that, right? A football is oblong. Maybe a rugby ball is oblong too, right? So there's other kinds. There's not a lot though. Most of them are spherical, but there are other shapes. So those are a way we could classify them, right? We could also classify them or put them into groups of the same color. But again, colors aren't numerical. They're not a number. So these two, when we talk about scatter plots, are not allowable because they're not numerical based. And we have different kinds of data displays to represent categorical data, right? So in scatter plots, it has to be numerical, which means we could use any of these ways to classify a sports ball. But because it's a scatter plot and we're dealing with bivariate data, remember that means two, we could only deal with two of these kinds at a time, right? I could compare the diameter to the weight, or I could do the weight to the density, or I could do the diameter to the density, right? But we can't do all three, okay? So these would be different numerical data I could use to put on a scatter plot, right? Now, what would we do with that? That's what we're going to be covering in the weeks to come. So what we do with the data, we don't really need to worry about right now. All we're thinking about is what kind of data can we use, right? People are the same thing. So each one of those points could be a person. And how can we represent people? Again, all sorts of different things. There's a lot more for people. I just got to 6 and I figured that was enough, right? So how can we classify people? We can classify people by their race. We can classify them by their ethnicity. We can classify them by their gender. We can classify them by their height, their weight, their blood pressure. Okay. So before I reveal it, real quickly think about which one of these do you think we could use to create a scatter plot. All right, hopefully you got something in your head. But if we go down the list, race, that's a category. You can't represent that by a number, right? 1, 2, 3, 4. So that's not something we could use to represent people on a scatter plot. Ethnicity, same thing. That's a group. Can't use that. Gender, again, it's not numerical based. It's a category. It's not usable. Height, I can say we represent that with a number. So height would be allowable. Same with weight. That's numerical based. Blood pressure, right? That's represented by a number. So all of these are different ways we could represent a person numerically. And again, if we're going to put it on a scatter plot, we would just pick 2 at a time. Okay? That's pretty much it. Just to give you a real quick run through of this graph, now that we talked about it, this is representing people, right? So each dot is a person. And how I'm representing the people here is their height compared to their age, right? Again, 2 numbers. So like this person is, in the grand scheme of this whole thing, I don't have actual numbers, but just compared to the rest of the data, they're about medium height and about medium age, right? This person right here is shorter, but they're also younger, right? This person up here is taller and older. Okay, so this is just a made-up chart. This was not real data. So, but that's how you would read it. This first task that you're going to be asked to do on Khan Academy, all you're doing is creating scatter plots. So it's just going to have some tables and a graph, and you just got to plot those points on the table.